Hello everybody, welcome to this live stream. Very happy that you were able to join today. What I'm going to do is sort of a little experiment, and it's called Under the Hood. And what we're going to do is we'll take a look at an open source library together. We'll look at the code, how everything's been set up, how it's been designed, maybe share some thoughts of what I think could be improved, what you think could be improved. Now, the interesting thing is that I am completely unprepared. So I don't know which library we're going to take a look at. I have these 3 envelopes right here that my teammate Andreas prepared. I don't know which one we're going to use. Of course, I created a little Python script for this to randomly select one of these envelopes in a minute. And this contains the library that we're going to take a look at together. Now, why am I doing this? Well, I think for me, what's really, I think, an interesting thing to look at is that we basically just see the live reaction of this type of code, open source code, and see what we think of it. And hopefully it will also show you that, you know, I'm just like you, just a human being, make mistakes, I'm going to overlook things, and together we're going to explore the code and hopefully learn a lot from that. And what I also hope is that this is going to help you see that open source code is not magic, right? It's just people like you and me that are writing, that are working on these open source projects. And I hope it will also motivate you to contribute as well to the open source community. And then at the end of this live stream, of this, let's say, code reviewing session, I'm going to give the library package a grade between 1, which is complete and utter trash, and 10, which is the best library ever that everybody should use as an example for their own code. Now, what I'm going to do is I'm going to switch to my code editor. And as you can see, I have a little Python script here to just print randomly A, B, or C. So I'm just going to run this, and that's going to decide which of these envelopes I'm going to open, and then we'll dive into the code. So there we go. Apparently it's C, so these ones, I'm just going to put them away. And we have envelope C, and let's see what's inside the envelope. Fortunately, these are the types of envelope where you don't have to use like your tongue, you know, to close them, which is a bit disgusting. This just has like a little strip to remove. It's way more hygienic. All right, so this is the library we're going to take a look at. Faker. Has anybody used this package before? Faker. Let me know in the comments. All right, so what I'm going to do is I'm going to switch to the browser. There we go. And then I'm just going to look for Faker GitHub. And then, yes, there we go. And now we have the code right here. All right, then. So I'll just say hello to everybody. See, there's quite a few people here from Belarus, Brazil, Tripstadt, Ukraine. Welcome, welcome. Very good. Okay, Faker. Now, let's take a look at what this actually does. I'll just scroll down. So basically what this does is, it's a library that generates, I'm just reading this, generates massive amounts of fake data. I might have used this in a project a while back, I'm not entirely sure. But I think it's going to be interesting to look at what this library actually does. Now, Andreas, my teammate, he also prepared a few notes for me. So again, I haven't looked at the code at all. I have no idea what we're going to encounter, but at least he's written down a few things that we could take a look at. So let's see what we have here. And so there's already one thing that you can notice, and that's, I think, common in lots of these open source projects, that you have lots of boilerplate files, right? We have all sorts of dot whatever files, like of course common ones like gitignore to ignore a bunch of files, but we also have configuration files, versions, changelog, etc. Overall, I think it's a really good thing if you see that, because that means that the maintainers of the library have put a lot of effort into making sure that everything surrounding the package is also being organized well. So I think that's already something really important to know, that when you, maybe if you start yourself an open source package or you want to contribute to a package, that there are processes around it that you need to think about. It's not just about the code. Now, let's see what we have here. So it looks like they also use VS Code. Another thing that you can see is Cypress. So this is a software testing package, and it looks like they use that mainly for end-to-end testing. So this is actually not Python code, but we can see that there is some TypeScript test here. Not entirely sure why they would need this if this is a purely Python package. Although I might actually look at the wrong package. Wait, let me just make a check. Yeah, so actually this is not the Faker package that we're going to take a look at. Wait. There you see, not prepared at all. Okay. All right, here, Faker. This is the real one. We might also take a look at the other one at some point, who knows. All right, so actually the same as what I said before. It generates fake data, so that's good. This one also does that. Okay, let's take a look at the code. So a few common folders that you're going to often see is, of course, docs, which will have documentation. Faker, this contains the actual package code, and there's also a test folder. So that's already a good thing, right? That's we have a number of tests to see what the package is doing and verify that some basic things actually work as intended. Let's just start with what's in here. So as you can see, there's already quite a few different files here. So when you look at the tests themselves, we can see that the commits are mostly a while ago. There are some commits from a few months back. Here there's something more recent. So if we look at what this is, so yeah, okay, so these are more the providers for generating the various fake data. So there is actually active work on the tests, which is nice. Let's open up one of these files and see what this looks like. So they use unit tests for this, which is perfectly fine, of course. So we have a setup where there's actually, this is actually a fixture that's been used in the test. And then there is a test. So the way that this is set up, that's actually nice, is that we have one class per test, it looks like. Oh, no, that's actually not true. We have basically one class per type of thing that you probably need. Yeah. So here there's no locale, here there is a locale US. And then there's various tests. One thing to be a bit mindful of is if you have a test like this, for example, is that you, when you write your test, don't put too many asserts in a single test. That's easy to, when a test breaks, then you have to dive into which assert actually broke, and that's kind of hard to follow. So it's better to keep it to one assert per test. Yeah, that's definitely a problem. I would definitely split this up into separate tests to make sure that you know, it's easy to understand what goes well and what goes wrong. Okay, so I'll just go back out of the test and I'd like to look at the actual source code. So we dive into the package. Okay. So maybe I'll start with this, the command line interface. So there's a command line interface for the Faker package, and that might be interesting to look at how that works. So it seems like they use some sort of generics somewhere in the code. I'm going to be interested to see where that is actually happening. Oh, that's actually here. One thing that I think could be nice to improve here is, it's a minor thing, but if you use a more recent Python version, you actually don't need to import dict and list from the typing package. You can simply use the lowercase dictionary and list. Union also I wouldn't use. You can simply use the union sign for that instead of the union word, which is a bit shorter. All right, let's see. What else do we have? So this is a function, print provider. There is no documentation whatsoever, so we kind of have to guess what this actually does. It looks like this prints information about the provider for the data. So what does it actually print? Let's see, it prints the name of the provider. And then what does this actually do? This prints the formatters, it seems. So this is maybe a helper function for printing information about the kind of provider you're using. That would be my guess. Let's see. Yeah, so I think that's one thing that I would maybe spend a bit of time on if I were a maintainer of this package, to make it clearer what these functions actually do, because it's not entirely clear from just the function signature. What is nice though is that they're using type annotations. Not all libraries are doing that, and I really appreciate that they do, even though they could use a lowercase list and dictionary. Also, I'd say this function is pretty long, so I think it would be nice to split this up. One way you could split this up is that we take the for loop, for example, and then basically what this does is that for each of the formatters, this prints some information about the formatters. And instead of doing it this way, it would be nice if a formatter itself could have a method that would turn it into a string, and then that would include basically all of this code, so that this function would be a bit shorter. Then we have a function for printing a documentation. There's quite a bit of complicated logic in here, though. What I like is that at the beginning of the function there is some sort of guard clause, like, okay, if or actually it's not a guard clause, this is really more like a default value. So if args is none, then it's the empty list. Yeah, this is kind of a workaround for, I mean, you shouldn't assign the empty list as a default value here, because the list is a mutable object in Python, so that's not something that you should do. So this is sort of a workaround for that. It's not that pretty, but well, what can we do? And here probably the same, where you don't want to pass this as a default argument. I'm not sure what this is. Is this some sort of object? Yeah, you might actually be able to pass this as a default argument directly in the function signature. Not entirely sure. Okay. Let's see. So then we have a bunch of pretty complicated logic here with nested if-else statements. There is even a while loop here. I think this also would benefit from splitting things up a bit more. Honestly, it's something that you're going to see a lot in these open source libraries, where I think it's a pretty common tendency that you actually write code that's not really split up all that well. What is nice, though, is that it seems to be based around a few simple functions, which is good. So there's at least some level of organization here. We have class command. That looks like to be the actual CLI command. And let's see what else. We have a parser, so this uses argparse. So it looks like they built a CLI on top of the argparse library, which is a built-in library, so that's nice. What might be good is to use something a bit more advanced, like Click, for example, which is a nice library. I recently recorded a video about that. I really liked it quite a lot, so that might make this code a bit shorter. Then let's see what else we have here. So we have have a command class that is sort of a wrapper around argparse. So that's nice. Let's see. And then we have all the various arguments here that are added to the parser. So now I'm wondering where the mapping is from the actual CLI to the actual operations that need to be performed. So let's see, this creates, yeah, so this is the actual CLI. So this creates the command, and then does command.execute. And command.execute, what does that do? So that creates the parser. So where does that happen? That is a bit weird. Oh, right. So, okay. So this belongs to the parser, actually. And then there is an action right here. Okay, okay. Okay, so this seems to mostly print things and then take that from the actual code. All right, yeah, yeah. So the question is, I think that's, especially when you're developing a CLI, like how do you combine the CLI code, so things like how to deal with the options and arguments and things like that, and the syntax of the CLI and the operations. Ideally, those would be completely separated, right? So you have the operations that can basically be run independently of CLI. So you could also use, I don't know, a GUI to access them, and then you have the actual interface elements like the CLI. So here it's not entirely clear to me how that actually is put together. It looks like this just directly uses these things, documenter, base, provider. Let's take a look at what this actually is. So what is the, let's take a look at documenter, for example. So what does that do? Okay, so that's a class, documenter, that gets a generator. And this has providers for which to write the documentation. All right. And then there are some methods like getting the formatters. Getting the formatters for a particular provider, as it looks like. Yeah. Okay. So I think that's one of the problems that you have to solve in a package like this, right? So this is able to generate all sorts of different data. So what you want in this case is a sort of design where you're able to add like new generators of new data types. And that's also when you look at the design of how this is organized, that we have providers. So these are the various, or you could almost call them plugins, right? For the different kind of data types that you want to generate. For example, let's take a look at some of these. So here we have bank, for example. So that's probably going to generate like IBAN numbers or something like that. Since I'm Dutch, is there Dutch IBAN? Yeah, let's see. Okay. So this is empty. Why is this empty? Ah, okay. Okay. So the .init file or the .init file actually contains code. So this imports a provider, and then it creates it kind of. Oh, this is interesting. Okay, so what this does, this imports a provider class, and then creates an alias bank provider, and then it creates a subclass called provider. So it overrides sort of the original class name and then implements that for a particular country, in this case for the Netherlands. I'm not sure I like this approach that much. On the one hand, I think it's kind of surprising that you put actual code in the .init file. I typically wouldn't do that. I would put that in a separate file to make things easier to understand. Also, I'm not sure I'm a fan of importing a class, naming it something else, and then inheriting from that, and then naming it again the same class. That's probably the sort of plugin mechanism that they use, so that you can simply import provider from your particular provider file and then just use that without knowing what it actually is. I would, I think, do this slightly differently. I would still use inheritance, probably, or maybe just expose a function, because actually that's not that much more that you need to do. Let's take a look at the provider class, actually. So the provider class, that should be, let's take a look. That should then be at the level above this, right? Because if we look at bank, so is this the same for all the providers? Yeah, so from ... import provider as bank provider. So that means that I would expect to find this provider basically at the level here. But it's not here. Is that here? Ah, okay. So that's also in the Dunder init file. Yeah, I'm not a fan of that. I think Dunder init files shouldn't be used to contain like a bunch of code, to be honest. I think they're mainly there for organizing imports and organizing your modules and the directories, not for providing actual implementation, in my opinion. So I would have put this in a different file. Okay. Yeah, so the way that it then works is then if you import from bank, then you're going to have access to a provider class. But if you import it from bank/language, then you're going to get that particular provider, which is a solution, but honestly, I'm not a big fan. Okay, so again, for typing, you don't need this import. You can use lowercase dict, which is good. And then what does the provider actually do? So it has a couple of methods that generate various things related to the bank. So we have an ABA routing transit number. So what does this do? Does it use a random or something? Or how does this actually work? Yeah, okay, self.randomInt, yeah. Then it has things like country codes. It has various bank accounts generators. So this uses also some random functions. Those are then probably part of the class. So there is a base provider that you inherit from. And then most probably base provider that has the methods like random int and random element and things like that. So it heavily relies on inheritance to provide information, right? So there's the base provider, which actually let's also take a look at the base provider. So then that means if it's set up the same, there should be a Dunder init file. Yeah, there we go. And then this should have the base provider. Okay, yeah, there we go. We have a base provider. So this is what all the data providers inherit from. And I think that's where you can also see the issue in, if you follow a design where you're heavily reliant on inheritance. Actually, inheritance is a really strong type of coupling. It's one of the strongest types of coupling that you can actually have. And that's, I think, also pretty clear that you can see that's going on here, where we have a base provider, and because we need to pass all that information via inheritance, it means that base provider needs to be a really large class because it needs to supply everything to any provider that inherits from it. I think that's the first issue with this. The second issue that I have with this is that if you want to, let's say, have a new type of provider that's dependent on a new type of information that's not in the base provider, you're going to need to extend the superclass with that. And that is going to affect any of the other providers that inherit from base provider. And it may actually lead to all sorts of conflicts. This is exactly the problem with object-oriented code. Also, I think that this information, so language locale codes, shouldn't be in a Python file. That should be in, I don't know, could be a text file like a JSON file, for example, or maybe even a SQLite database that contains like base data that you would need, right? And I would actually completely split this out. So instead of having this be part of a base provider, I would simply supply this data in another module. And then if you need it, you import the module and you access the values. And it's as simple as that. There's no need for an inheritance relationship here. Let's scroll down. Let's see what else we have here. So here it's pretty clear this makes the code really hard to read, right? Because if we want to know what is going on in the base provider, we first have to scroll down 3 pages of code to get to the actual fun part, which is here. So there's some helper methods here to generate some things like locale or a language code and things like that. And then we have methods for generating various types of random data. Yeah, so I guess that could work, but again, you're really creating a pretty strict pipeline of going from the superclass to the subclass. So if for example, let's say I wanted to change the name of this method, right? Now I'd have to change that everywhere in any of the subclasses. And same goes for any of these other methods, and that's just really annoying if you have to do that. So I would be very careful with setting up your code this way. Personally, I much prefer a more functional approach where you have modules that have a few simple functions that you can then use in the various other places in your code. And then those functions are also easier to test. Because now, testing the base provider class is actually going to be pretty complicated because it's a huge class, right? How many lines of code are there in this class? So it's almost, 730 lines of code, which is a lot. This is actually another class. So let's say almost 700 lines of code, which means that the class is really hard to work on because you're gonna spend a lot of time trying to figure out where is what. So I think for me, one of the ways that I would set this up is that I would think about generating data as something that happens on various levels, because in the end, generating a random number is also a very low level data generation system, right? If you just need one random number, you generate data, which is one random number. And then if you want something else like a character, you generate a character. But then maybe you want to put a layer on top of that where you don't generate a single character but a string. And then maybe on top of that, you want to put a layer where you don't generate a string, but maybe you generate an address with a street name and a house number, and you build up layers like this. And to me, that would be like a nicer way of doing that, and then basically representing these layers that you have in using various simple functions that you can then compose. Okay. So let's scroll back up. What else do we have here? So I'm going to, again, the Faker package, and let's see what else we have here. Okay, so there's also this proxy. What does that actually do? Let's see what that actually does. Okay, so this is a proxy class. It's also called Faker. So what is it a proxy of? Let's see. Okay, this seems to work on top of a locale, which is a string. Okay, so this has a factory of various other generators or fakers. So that's what it seems to be a proxy of. So where is the factory map being used? Let's see. Yeah, here, for example. Okay. So this is, it's still in the initializer. All right. I think this is here where it's being used. Okay, so yeah, so you see basically that we have the methods in the proxy class that then access the factory map, and there's also a factories object. So what's the difference? What is the difference? Oh, okay, so factories, it looks like that's just a shortcut for the actual factory map. So, yeah, okay, so this creates for each locale, it creates a faker object for that particular locale. And this faker object, what is that? That's not this class, right? Or is it? There's not another import, yeah, so that's actually, okay. So this is also interesting. This is also interesting. The class initializer, generates instances of itself. So there is a sort of recursive thing going on here. There's something recursive going on here. And what happens is that for each locale, this creates a faker object, which is a proxy class for that particular locale. And that means that every time you call this, that's going to end up here, because the length of this is going to be 1. So this is a really weird way to set things up. This is really weird. I think, yeah, so Ernesto says, isn't the lack of documentation a problem? Would help a lot. I totally agree, actually. I think there are some really special design things going on here, and this would definitely benefit from an explanation of why it's set up in this way. To me, this feels like it's very complicated. I'm not sure what this actually is supposed to solve. The only thing that this says is that it's capable of supporting multiple locales. So it looks like this is a way to avoid having to write different code for doing something for a single locale versus doing something for multiple locales. Because then for multiple, you have multiple objects, and then it's solved in that way. But that's like, to me, it's a really weird way to do it. If I would want the code to behave the same for single things versus lists of things, then I would simply write a wrapper that converts the single thing into a list. And then you can, on the lower level, always work with lists, right? All right. Let's see what else we have. Oh, exceptions. That might also be nice to look at. Okay, so one thing. Okay, so this is nice. This is something that I like to see in open source packages. So we have, if you're dealing with exceptions in Python, right? You can create, or you can raise standard Python exceptions like value error and things like that. Here what they did is that they created a subclass of exception called base faker exception. And that's the base exception class for all the faker exceptions. And then there are two subclasses, uniqueness exception, to avoid infinite loops after a certain number of attempts. Unique attribute of the proxy will throw this exception, all right? And then we have unsupported feature. Requested feature is not available on this system. So these are apparently the only two types of exceptions that this package can raise. And the nice thing about setting it up in this way is that you can now be sure, at least you hope that this is all, that if you catch the base faker exception object, if you have a try except block, for example, that you are sure you will always catch the exceptions that are generated by this package. But if there's something else going on that's not being raised by the code in this package, then you will get another type of exception. So that makes it easier to handle exceptions from a particular package. So that's nice. So I highly recommend, if you work on some project or a separate library, create a simple exception hierarchy for that particular package that inherits from the exception class, just like they do here. Now the question is, are these actually the only exceptions that are being raised? Because if I remember correctly, let's go back to the bank. If I remember correctly, there was some exception raising here as well, or maybe not here. Maybe it was in this .donder init file. Okay. So this raises an assertion error. So I think that's problematic. So on the one hand, the package sort of promises or sort of says, hey, there is a base exception class for all the exceptions that the package raises. But at the same time, if you go to this file, it actually raises something else, which is an assertion error right here. And I'm quite sure we can find more examples of this if we dive deeper in the code. So that's really an issue, because that means that the package sort of pretends to be precise in terms of raising errors, but then at the same time actually doesn't really keep the promise of raising only those types of exceptions. So I think that's something to be really careful of, that if you promise that as a package, that you actually only raise those types of exceptions that fall under the in this case base faker exception class, and not any other exceptions. But it's really hard to be consistent in that. All right, let's see, what else can we take a look at in this package? What else can we take a look at? That's another thing that's also interesting. So if you publish an open source package and you want typing information to be there, you need to supply these stub files. So I don't think it's a really great approach, honestly. It's not the faker's package fault, right? This is just how Python's type system works for packages. But I don't really like that you have to duplicate the classes and supply the typing there. Now maybe you can generate this automatically. I don't know what kind of tools they're using for this, so maybe that's possible. But having to write this manually is kind of a pain. So I hope that will get better with Python in the future. But basically what you see here, this is really just a stub file for the type information for, in this case, the faker class. So you see that it has a bunch of methods like generating address, or let's see, what else do we have? Building number, city, country, language codes, lots of other things, postal code, random choices. Honestly though, when I look at this class, so this is obviously a huge class, I think there's actually a pretty serious design issue here. I'm going to take another look at this proxy class. Okay, so the proxy class. Okay, so the way this seems to work is that there is this idea of providers, which provide different kind of generators for data, bank accounts, currencies, dates and times, whatever, right? That looks like it's a nice design, because if we want to add support for something else that's not in this particular list, we can add a folder and we can add the specific type of provider, and then we can generate data of that particular type. However, the problem is that now in your type stubs, you actually also need to add a method to the faker class here. And that's because of this whole proxy mechanism. Because every time you add a new type of data provider, it means you add methods to actually generate that particular type of data. So the if you, for example, look at, let's say, providers and then the address, right? And then we have the various languages. Okay, so this seems to be set up mostly in the same way. So let's say I'm Dutch, so let's go for another Dutch address. And yeah, so this generates random Dutch address. I don't know why this. So okay, these are all the Dutch towns. There's lots of towns here, actually. Again, I don't think this should be in directly in Python code. This should be in a separate file. So many. Okay. So how complete is this? Ah, look. That is my birthplace. Actually, that's what, no, it's not my birthplace. It's where I grew up. I lived there for 18 years. Interesting. Okay. Okay. This is really bad. I think this kind of information shouldn't be in a Python file. It should be in a separate data file. But so back to the problem. The problem is that so address generates these things: city, administrative unit. If I scroll all the way back up, we have what is it? Oh, maybe I shouldn't have scrolled all the way back up. But there's like a couple of different methods here that generate something. But then you would think that that would then be separated from the rest of the code. But that's actually not true, because if you look at the type stub files, now we also have to manually provide those extra methods here. And that breaks the separation that you achieved by decoupling things. So I think the core of the problem here is that because of the whole setup with the proxy classes and overriding the class name, the provider name, the thing that we talked about in the beginning, it means that this is the only way you can do it, because now you're forced to have to manually update this stub file, because if you add support for a particular type of data, that means you need to add it here. Another way to approach this, I think, is that you don't have method names that reflect the thing that you generate, but that the name of the generator itself is what actually determines what you're going to generate. And then the type of that could be generic. So it could have a method for generating various basic data structures, and you could even use Python generics to generate things of specific object types. So in my opinion, there's, in particular in terms of the typing, there's a lot to improve here. So that's what I would say. What are your thoughts about this? How would you design this type of plugin mechanism? What would you do differently? Let me know. Okay, anything else we want to take a look at? Should we take a look at typing? Is that interesting? Okay, so these look like they are sort of maybe system or global level helper types. So we have a credit card, which feels a bit random to me that this is here. This to me is a pretty specific type of data that shouldn't be in here. I mean, I can sort of understand that you have things like basic number or date or a seed type, or things that are really not directly related to particular data types. But I think having a credit card here, to me, that doesn't make sense. That's a very specific type of information. So that, to me, that doesn't belong here. All right, so Ben, specifically for addresses, if they're okay with using external data source ID, use an API, like Google Maps API. It saves about 22 lines of code and readability. Yeah, that's definitely true. I do, yeah. So I think that indeed the advantage is that it results in shorter code for sure. The only issue is that APIs can cost money. And of course, I mean, the Google API is not ridiculously expensive or something, but if you do many requests, then it can start to add up, and you're dependent on the service of Google being available, whereas it is actually nice if something is isolated. In particular, what would be a main use case for a package like Faker, right? I'd say this is something that you would use in test setups. I think somebody also mentioned that you can, Marek says that it's a great tool to work together with Hypothesis for property-based testing. So you would typically use this for writing automated software tests. And the question is whether you really want those to be dependent on external APIs. I think for testing, to me at least, it's important that these are deterministic and that it's clear where the data is coming from. So if you provide a particular seed, that's why Faker also has seed support, then you know exactly what you're going to get. And that means it's way more predictable than using external API like Faker or like Google's API, for example. So to me, that's an important reason why you don't want this kind of test data to be dependent on external APIs. And on top of that, maybe your test running setup is something that you really want to isolate and not accidentally expose to the internet, right? It might just be on a very simple server somewhere. If you don't have internet access, then you still want to be able to run your software tests. So for testing, to be honest, the less dependencies you have, the better, because then you can really focus on testing the actual code. So Peter says, a bit of a noob question, but why wouldn't you put the typing in the regular proxy.py file? Yeah, so this is basically just the way that a package publication works. So the typing information is extracted or is retrieved from a .pyi file. That's just how it's been defined, and that's how it works. It's as far as I know, it can't take that from .py file. So, which is a pity. I think it could be simplified a lot, but well, what can you do, right? Squishy tomato. There's some low frequency noise in the microphone, like wind or other movement. Yeah, I have the airco turned on. That might be the reason why. I could actually turn it off for a bit. This is like the oldest remote ever. Wait. Okay. Because, well, we are in a very rare situation in the Netherlands where it's actually pretty warm outside. So we're not used to that. Vera asks, what is your keyboard? This is the one I'm using. It's the Nufi Air 75. It's pretty nice. I did a review of some mechanical keyboards a while back. Okay, so I hope without the airco that solves the rumbliness. Let's hope that's a bit better. Right. So let's see. I think we kind of went over the most important things of this package. One thing that I do notice in this particular package, and I think it's a common theme in other packages as well, is that there's a very limited dependency on abstractions. Things like abstract base classes, protocols, things like that. I'm not sure why that is. Maybe that's just more of a Python thing. I mean, if you look at this code and how it's set up, to me this is not a straightforward way of working with classes, that we have this huge base provider class, then we make subclasses of that, and then depending on which module we import, we override which class we actually get. I think it's really not a very nice way of how it's set up. I think by sticking with simpler, if we use object-oriented programming, if we stick with simpler concepts and really use it in a more limited way, I think that makes more sense. So yeah, so Justin says, all of this typing and proxy stuff has gone a little over my head. Can you summarize on a high level what the problems were with this multi-provider proxy issue? Yeah, so what happens is we have, that's what you see here. So Faker generates data, right? And data is generated by providers. And we have providers for different types of data. We have one for bank accounts, we have one for barcodes, we have for colors, company names, credit cards, whatever, right? So on a surface level, that looks like it's a good idea, right? That each provider is responsible for generating the data of its particular type. So the currency provider, for example, is a class that is responsible for, well, providing currencies, which is nice, right? And the idea being that if you want to add support for another type of data, we just add another provider. The problem with how it's set up is that this is really messy in the way that this is organized. Like, I would expect that a provider for any type of data would follow a very specific kind of abstract structure, right? And then once you follow that structure, that contract, then you can inject it into the Faker system, and then you can use that provider. But that's not how it works. The way that it works is that each provider here creates a subclass of the base provider. That's what you see here. And then it kind of messes with the way that you import things. So if we want, in this case, this is credit cards. If we want to generate English credit cards, then we import from creditcard.enus, and then it overrides the original credit card provider. And here it does nothing, but if you take a look at another language, like, I don't know, yeah, whatever, here you see it's going to do something different. So your import determines what kind of specific provider you get, and that then overrides a particular class. And that means that instead of using the common object-oriented mechanisms, you're messing around with imports to override things. And then on top of that, the problem is that that there is, at the top level, there is a proxy class that then puts all of that together. And then in the type definition of that, you then have all the specific things of all the different providers. So that means that it doesn't work the way that you think it does. It's not that we can simply add a class here and it will just work. No, we also have to go into the type stub and then add this provider-specific methods here. So this is supposed to be something generic, which is part of the Faker system, but we have to be specific about provider implementations. And that's what bothers me about the way that this is designed. I think providers should be completely separate from the Faker system. And the only thing you should do when you initialize the Faker system is basically indicate, you can even use just strings for that, which providers you want to use. And then Faker can import them and then you use them without having the dependency on knowing the specific types of methods that each of the providers have. So I hope that's basically, in summary, what I think is the problem in terms of design with this code. I hope that helps, Justin. Now, before I finish this live stream. So let me just switch back to the full screen. So I just, if you have, I just want to answer a couple of your questions. So if you have any questions, it doesn't have to be about this particular code, just ask any question you like, and I can do a quick Q&A session, right? So Rondolph says, what language do you think a beginner should learn if they're trying to get into web development? Well, the most common language in web development is obviously JavaScript. So I think that's a really good start, right? I think that JavaScript is also a relatively easy language to learn, though it has some idiosyncrasies, but it is the most common language that's being used. You might spring to TypeScript instead, because that's a nice extension of JavaScript that adds type information, and that's actually definitely helpful. It's going to make your development journey a lot easier if you use TypeScript. So definitely TypeScript, JavaScript, those are a great start. And look at, let's say, a few simple frameworks. There's HTMX now, which is getting popular, which is a really simple way of developing web applications. You could go and look at React, but that's I'm not sure how long React will still stay popular if these simple frameworks really take off, but take a look at that. Ben, God forbid they change the directory structure, everything breaks. Yeah, absolutely. Yeah, so that whole provider system, it's really, I'd call it really fragile, exactly because of that reason. We have all this coupling everywhere, so I would definitely design that completely differently. Vera asks, will you make a video about provider? What's the difference with factory? I can definitely do that. Thanks for the suggestion. They are actually kind of related in that they each provide an abstraction layer on top of supplying information, whether that's objects, what a factory does, or data, which is more what the provider does. Machadino says, have you tried UV, the Python package manager? Actually, I haven't, but I'll definitely take a look at that. Ben, thanks for the deep dive. Arjan, very cool. Well, I'm glad that you liked it. And that also reminds me. So, like I said in the beginning of the stream, this is really an experiment, right? I thought it might be cool to do this, but I'd really love to hear from you what you think about this. Should I do more of these? Do you have particular open source projects that you would like me to take a look at in a live stream like this? You can let me know in the chat. You can also, if you're watching this after the stream itself, you can post a comment and just let me know what you like. And basically, depending on what you prefer, I will not do more of these, or I'll do another one, or let's just see what you think about this. Now, I'm not going to turn this into, like, at least not for the time being, into a weekly recurring thing. I want to keep it kind of open. When I have time to do one of these sessions, and I'm definitely going to do that. So if you like this deep dive into open source projects, then I'll instruct Andreas to create a few more of these envelopes. And then, we'll do another session. We'll take a look at another library, and hopefully we can learn together more about open source projects. And it's hopefully going to be a fun time to hang around together. So, thank you so much for joining today. I wish you a great rest of your day, and we'll see each other soon. Bye-bye.